So dear students, this important video is related to projectile on an inclined plane. So if for example there is a hill and there is a pair of friends who are standing on this hill and I throw this ball towards my friend, he catches it. So this figure shows it somewhat like this. You may be standing here, your friend is here, you are throwing it to this friend, some ball, and it goes here and strikes this. So just see, look carefully that this projectile does not know that there is an inclined plane. So just remove out of your mind that the projectile has a knowledge in the first place that there is some inclined plane and I have to travel on this. इसको आप हटा भी दें, this projectile will go like this and fall to this ground. Sometimes we think that the projectile is aware that this inclined plane has come, so I should change my motion or trajectory, my way of movement, which is not correct. But what is important here is that this inclined plane makes an angle alpha with the horizontal. This straight से angle बना रहा है alpha, and when I am throwing this projectile, it makes an angle theta with this horizontal. So therefore, with this inclined plane, it is making an angle of theta minus alpha. Are you clear about this? This inclined plane, suppose it at 30 degrees, and I am throwing it at 75 degrees. This projectile. So यहाँ से what angle will it make? It will be 75 minus 30, that is 45 degree with this inclined plane. Now the very important point is we can do two things here. We can choose this as x dash and this axis as y dash. So I can choose the normal axis x dash and y dash, or I can choose x and y. So in these videos I want to cut short the discussions because my focus is on making you people equipped with skills for problem solving. So I am not going into very long stories. So I'll just wade through this topic and take you to problem solving because that is where the people feel challenged. So on this inclined plane we have the same theory, that is G is constant here and air resistance is neglected. The same thing which I said for the projectile motion. You can look into the videos of projectile motion if you have not seen before coming to this topic. Now the important questions that can be asked is, what is the time of flight, that is from O to P? What is this range? Now this is the range here. What is the maximum height above this? So you can see that this is the maximum height above this ground when you throw it. But he is asking the maximum height above this inclined plane. मतलब inclined plane पे maximum height क्या है? तो अगर आप ध्यान से देखोगे तो यहाँ तक increase हो रही कहीं यहाँ पे ये maximum है, उसके बाद कम हो जाती है. Here it is somewhat maximum and then it gets reduced. We are confused about how to make our calculations. Now I'll tell you that for two things, that is time of flight and maximum height above the incline, इन दोनों चीजों के लिए हम ये वाला x और y चूज करेंगे. The reason is, देखिए जब ये यहां से जाके यहां पे वापस आएगा, when it comes from O to P, then in this direction, when it comes from here to here, then in this direction its displacement is zero. Just like when I am here and I throw it and then it comes here to here, then displacement in this direction is zero, vertical direction. So now along this axis, y axis, the displacement is zero. But इसमें एक और प्रॉब्लम भी आ जाती है, जैसे कि आपका G is like this, suppose, but this G is like this, perpendicular to this, or in this y dash direction, you can say. So if you choose this x and this y, then both components of acceleration appear. मतलब इस acceleration का एक component इधर भी आएगा और एक component इधर भी आएगा. तो obviously देखिए ये जो एंगल है मेरा, ये भी अल्फा है, ये भी अल्फा है, तो ये g cos अल्फा बन जाता है, ये g sin अल्फा बन जाता है. So this is the challenge which appears here, that there are both components of acceleration in x direction as well as y direction, but this is x, this is y. So we have ax, that is in this direction we have an acceleration that is minus g sine alpha. And why I am writing minus sign? Because this I assume as positive direction, so this is negative direction. This is positive, this is negative. So ay equals to minus g cos alpha. Now in normal projectile ax is 0. That's what I said. This is uniform motion. But here in this direction and in this direction, in both these directions, uniform motion is not there because there is ax and ay. Now suppose I want to calculate the time of flight. Like normally when you calculate the time of flight for this, you say sy is 0. Here also sy is 0, but y axis is not this but this. This I have named as y dash and x dash. So for time of flight, to calculate t, आप क्या लिखेंगे? You will write that sy is equal to 0. Now पहले sy की equation we should write first. Sy is equal to uyt plus half ayt square, and I am applying the same theory which I applied for this horizontal projectile, which was that sy is equal to 0. There also I said in this direction vertical displacement is 0. Now this vertical displacement is 0 क्योंकि यहाँ से यहाँ आ गया है. मतलब देखिए y एक्सिस पे पहले भी यहाँ पे था, अभी भी y एक्सिस पे यहीं पे है. सिर्फ x एक्सिस में it has moved, but this is x axis now. So if you write sy is 0 here and solve this carefully, देखिएगा t से t कट जाएगा तो t आ जाएगा आपका minus uy upon ay, और यही आपका हो जाएगा time of flight. So you will ask me, sir, is this negative? No, it will not be negative because you have to see what uy is. अब uy और ux भी वो नहीं है जो horizontal में थे, because then uy was u cos theta and u sin theta. But now you have to see this angle, and this angle is not theta. This is not even alpha. This angle is theta minus alpha. So this ux, when you say it is u cos theta minus alpha, means cos of this angle, and uy equals to u sin theta minus alpha. So more than remembering the results, see the analysis, because results may be difficult to remember for inclined. So don't remember it. This is u cos theta minus alpha, u sin theta minus alpha. So when you calculate it, this time of flight will be minus 2 uy u sin theta minus alpha upon ay is minus g cos alpha. So this is the answer. Now you can have other answers for this also. For example, theta minus alpha is this angle. Now suppose I give you this angle as theta itself, so theta will appear here. You are getting my point. Now I am giving you this angle as theta, this is alpha, so this is theta minus alpha. But suppose I give you this angle as alpha or beta, so here it will appear sine beta only. So the important thing is it is sine of this angle which this projectile makes with the inclined plane. So 2u sin theta minus alpha upon g cos alpha. Alpha is the angle of the inclined plane. Now you can check whether this holds good for the case when alpha is 0. Now when alpha is 0, here you get 2u sin theta upon g, which is the time of flight of a normal projectile. इसमें alpha को 0 put करके देखिएगा, it will become 2u sin theta, and this becomes cos of 0 is 1, 2u sin theta by g. So if this inclined plane is here, you get the normal projectile for which the time of flight is 2u sin theta by g. Now second is finding maximum height. Now, maximum height is somewhere here. Now see, it goes like this, like this, like this. At maximum height, once again, this component of velocity, so it goes, let us say, now you are looking from here, it goes up and up and up and up and then down. So in this direction, in y direction, the vertical component of velocity becomes 0. When you throw like this, then this vertical component becomes 0. When you throw like this, then this component becomes 0. So for maximum height, I think the board is visible here. So for maximum height, I am writing capital so you are not confused. आप क्या लिख सकते हैं? You can write Vy equals to 0. और कौन सी इक्वेशन यूज करेंगे हम? We will use the equation Vy square equals to Uy square. Now यहाँ पे क्या लिखें हम? क्योंकि अब g नहीं लिखेंगे हम लिखेंगे g cos alpha, g तब लिखते हैं when it is like this, now it's g cos alpha, so minus 2g cos alpha into h, and when Vy is 0 then h will become h maximum, so you can put Vy equals to 0 here and h equals to h maximum, so h maximum कितना आ गया, directly I am putting Vy as 0 in this and h as h maximum, तो ये h maximum बन गया, इसकी वैल्यू आ जाएगी uy square upon 2g cos alpha or uy is written here, so again you get an answer for the maximum height above this inclined plane. Now इस discussion में the most complicated thing is range, and we'll do a very small trick to calculate the range, because अगर आप ये रेंज निकालते हैं डायरेक्टली यहाँ से यहाँ तक, सो इट बिकम्स, ये यहाँ का x है तो आपके पास आ जाएगा uxt प्लस हाफ axt स्क्वायर, ut प्लस हाफ at स्क्वायर, ऐसा बन जाएगा. बट ux कितना होगा, u cos थीटा माइनस अल्फा, और ax कितना होगा माइनस g sin अल्फा, एंड टाइम विल बी द total time of flight which you got as this. So very complicated result. So can we make it simpler? Yes. So now what I do is just look at this trick for range. We forget this axis and I now remember these two axes, x dash and y dash. So I do a very small trick, and that is a very interesting trick. If you choose this as x axis and this as y axis, understand once again what I have done. Now we choose this as x and this as y to calculate time of flight and maximum height. Now what I do is I choose this as x, which I have written as x dash, and this as y, which I have written as y dash. Now for this axis, once again it's a uniform motion in this direction, the same thing which I told in projectile. So I am rubbing this board. If any problem, you can just go back and see. You can just go back. Just accelerations I'll let them be written, minus g sin alpha minus g cos alpha for these axes. But for x dash and y dash, you should remember, for x dash and y dash, अगर ये वाला choose करते हैं, so acceleration in x direction is 0. Sir, what are you telling? Why is it 0? अरे we are going back to the normal projectile where the acceleration in this direction is 0, and ay dash is what? That is equal to minus g. So don't be confused with this ax and ay. This was for these axes. Now I am talking of these axes. So ax dash is 0 and ay dash is minus g. So very easily, just see, if I drop a perpendicular from here, then for this projectile, when you see it from here, this is the horizontal distance. Now let me call it this distance as x. This distance I am calling as x, this one. So this distance is x. Now can I calculate x? And my answer is very easily. Why? Because for this axis, x is only ux into t. So here it will be ux dash into the time, which is capital T. अब आप थोड़े से कंफ्यूज होंगे इसमें, इसलिए मैं इसको और क्लियर कर देता हूँ. मैं आपसे कहना क्या चाह रहा हूँ, what I want to say is this capital T is the time of flight. Capital T is the time of flight which we calculated just now before rubbing this board. What time देखिए आप. Now suppose I want to find out कि in that time t how much has it traveled in this direction, that is x dash direction. So can we treat it as a normal projectile, and in normal projectile acceleration in x direction is 0. So x is only ux into t. So I am writing it as ux dash because ux I already wrote here. Now this ux dash is the component of velocity not along this, but along this. So ux dash is the component of this velocity in this direction, and ux dash is how much, can you tell me? Yes, now we won't take this angle or this angle, but this angle is theta, so it's simply u cos theta. So basically now I have converted into a normal projectile with this as the angle of projection. So x is u cos theta into time of flight. Why time of flight? Because time of flight is the time in which it strikes this point. So in this point I am calculating this distance by shifting my axis to this, and that is a very simple answer, u cos theta into t. But this is x. Now you will say, sir, हमको x थोड़ी निकालना था, हमको तो रेंज निकालना था ये वाला. we have to calculate this range, और आपने ये निकाल दिया. Yes, we have to calculate range, but I have found x, and this is a right triangle. Fortunately, this triangle is, see, this triangle is a right triangle. Now in this triangle, this, that is x upon this, which is the range. Range is this. So x upon r in this right triangle is based upon hypotenuse is cos alpha. तो मैं बड़े बड़े शब्दों में लिख देता हूं x upon r is equal to cos alpha, and therefore r is equal to x upon cos alpha. r is equal to x upon cos alpha. x मैंने यहां से निकाल लिया है, u cos theta into t. तो रेंज क्या आ जाएगा आपका? That gives me range is equal to this u cos theta into capital T by cos alpha. ये रेंज आ गया, बहुत आसानी के साथ आ गया है. u cos theta into टाइम ऑफ फ्लाइट. टाइम ऑफ फ्लाइट मैं नहीं लिख रहा हूं, आपके पीछे वाले पेज में था, वहां से आप कॉपी कर लीजिए इसको. u cos theta into t upon cos alpha. So I made a small trick. I shifted this axis. I found this distance as only u cos theta, this component. So this x component, ux dash, u cos theta, and u cos theta into this time of flight which I found from there is this distance, and then from this right triangle, this range is x upon cos alpha, or you can also have said x sec alpha, but okay, both the things are same. So x upon cos alpha, and x is your this distance which is u cos theta into t. So now we have found the range, time of flight, and maximum height above this inclined plane. Try to see this particular video 2-3 times. 2-3 times इस वीडियो को आप देखिए और समझिए मैंने क्या बताया. If there is any doubt, then you can message me. But I think it will be clear. But more important is the concepts which I am using. For example, I chose this as x and this as y. So ax was this and ay was this. If I choose this as x and this as y, then I choose ax dash is equal to 0. और अगर मैं यहाँ पे ay dash लिखना चाहता जो मैंने नहीं लिखा है तो क्या लिखता? माइनस g. ay dash, that is along this direction, minus g, this one, not this. So for this axis fy is minus g cos alpha, ax is minus g sin alpha, but for this and this axis ay is minus g and ax is equal to 0. So to differentiate between x and this axis, I wrote it as ax dash, ux dash, which is u cos theta. For range, I chose this axis. For height above this incline and the time of flight, I choose this and this as. So the key concept is the choice of your axis. So remember, axis you are always free to choose, but if you choose one pair of axis, then the components become fixed. The components become changed. You don't have the same components which you have along one particular axis. इस axis पे components कुछ अलग आएंगे, इस axis पे components कुछ अलग आएंगे. So much for now in this video, and we'll now move to problem solving. So there are certain videos where I am writing kinematics, projectile 1, 2, and some theory in the first part also. Now I'll write another heading, that is problems 1, problems 2. So when I write the name of the topic, then it is, you can say, theory plus some problems, and problems means it's just only the problems. So I finish this video here and see you in the next video. Thank you.